Hello, my name is Touma. My ID is 6359553, and this is the lab project report number 7 from group 2.
Hello, I am Hannah Contramaestre. My Panther ID is 6117264. Um,
Hi, hello. My name is Mohammed Alsabbaghe. This is my segment.
Here in activity 1, I had to create the circuit that you can see on the screen and making sure that the duty cycle was 0.5 or 50%, which I did for the VINT. And also, I had to change the frequency for the A, B, and C parts and see how the three different frequencies would change not only the graph but the other values of the circuit, which in this case we're mostly focusing on the volts. For the first one, I got as a result from the formula 0.1 kilohertz, which is the same as saying 100 hertz, as you can see on the screen for the circuit. And all the other values were not specific, so I chose them. And with that frequency, it created the graph that you can see on the screen, which shows how the voltage changes over time. Here for the second circuit, I had to change the frequency once again from 100 to 1 because in the formula it was basically getting the 100 that was stated in the part that was 100T and dividing it by 100, which is what I already had for the previous circuit. So it basically ended up being 1 hertz. And so that changed basically the value of voltage over time in the different sections of time, or in this case sections of seconds, as you can see on the graph that changed. And finally, for the last circuit, I had in the formula 1 over 100. So instead of dividing, this time I had to multiply. So it was basically going to end up being 10k hertz in this case for the frequency. And as you can see, the voltage once again changed based on the time intervals of seconds. What I concluded from the three examples that I had to work with is that this is a low pass filter circuit, and that the most important part that the frequency changes is that the greater the frequency, the smaller the voltage it gets per interval until it gets to a stable state. And also that all the circuits had the same kind of process where they went up and down in each interval, but always kept going higher and higher over time until it got to the, like I said, the stable part.
Hi, hello. My name is Mohammed. This is my submission for lab number 7. This is what I did for the first part. This is how it looks. This is what the graph looks like. The only difference between this one and the one I'm about to show you is this one is 200 hertz.
okay, so I did activity 2 of lab 7, and basically we're asked to build a circuit and we're asked to find the amplitude of VD, VAB, VAC, and VBC. And also calculate the RMS values. So this is all my work. Basically, I had to do it by hand because my computer had an aneurysm, I guess, and I haven't been able to go to school just because of all the floods that have been going on. Anyways, that's besides the point. So basically, for this, the circuit is a negative feedback loop. Right here we have all the givens. Basically our VM has to be less than or equal to 15V, and our omega has to be equal to 377 radians a second. So basically, as I said before, the circuit is in a negative feedback loop, so our Vin is equal to our Vm sine omega t, and then so for input voltage, we put our V DE equals to VM sine VW, and then we just replace all our values into it, and then we get 15 sine 377 TV. And then for our point AB or VAB, that's the center input, so we do the 15 sine 377 TV over 2. That's highlighted right here, it's on the left side. And then for our VAC, we do our VM sine WT, and then we do it's equal to 15 sine 377 T. So then we go to our our RMS values, and then we just basically do the math, and then we do 15 over the square root of 2, and then we get that is equal to 10.6 volts. And then we do the same exact thing for VAB and VAC, and so we just get our values. Our VAB is equal to 5.3 V, and then it's that, and then for our VAC it's equal to 10.6 V. So then for our turning ratio, we do our DE is the ratio of the VAB, so we just put that, and then we get a 2-to-1 ratio for this. And then for number 2, we get we do the same exact thing, and then we get a ratio of 2. And then if this thing can move, I don't know if you can see my screen. I think you can. But then for number 3, we do the same exact thing, and we get a ratio of 1. And that is basically our activity 2 of lab 7. Thank you.